Every day, thousands of satellites silently orbit our Earth, powering your GPS, enabling weather forecasts, and even streaming this video to your device. But have you ever wondered, how do satellites stay in orbit and not fall back to Earth? Today on Astrotech Universe, we'll break down the science of orbital motion in a way that's crystal clear. What is an orbit? An orbit is a curved path that an object follows around a planet, star, or moon. It happens when two forces, gravity and inertia, balance each other perfectly. Think of throwing a baseball. It falls to the ground. But if you could throw it fast enough, say 28,000 kilometers per hour, the curve of the Earth would drop away beneath it at the same rate it falls. That's an orbit. Gravity and inertia. Sir Isaac Newton explained it best. Gravity pulls the satellite toward Earth, but the satellite's inertia, its tendency to move in a straight line, keeps it from crashing down. It's like a cosmic tug of war. Gravity tries to pull the satellite down. Inertia tries to fling it into space. The result? The satellite falls around the Earth, not into it. Types of orbits. There are different types of orbits, each with unique speeds, altitudes, and purposes. Low Earth orbit, LEO, 200 to 2,000 kilometers above Earth. Fast, about 90 minutes per orbit. Used for satellites like the ISS, Starlink, and Earth observation. Medium Earth orbit, MEO, 2,000 to 35,000 kilometers. Used for GPS satellites. Geostationary orbit, GEO, 35,786 kilometers. Satellite appears to stay still over one spot on Earth, perfect for TV and weather. Each orbit has a specific speed. Too slow and the satellite falls, too fast and it escapes into space. Launch and placement. Satellites don't start in orbit. They're launched by rockets. The rocket carries the satellite high above the atmosphere, then releases it at the right altitude and velocity. Onboard thrusters or the rocket's upper stage adjusts its trajectory and inclination. That's the tilt of the orbit relative to Earth's equator. Speed and balance. The secret to staying in orbit is constant freefall. Satellites are falling toward Earth due to gravity, but their forward speed means they keep missing it. In LEO, satellites move incredibly fast, about 7.8 kilometers per second. In GEO, they move slower, around 3 kilometers per second, but the distance is greater. This perfect balance keeps them looping around Earth indefinitely, with only minor adjustments needed. Atmospheric drag and corrections. Satellites in lower orbits experience atmospheric drag, a tiny friction from particles in the upper atmosphere. Over time, this slows them down, causing their orbit to decay. To correct this, satellites use onboard thrusters to make slight orbital boosts. Without them, they'd eventually burn up like meteors. Satellite lifespan and end of life. Most satellites have limited fuel and lifespan, usually 5 to 15 years. Once they run out of fuel or become outdated, they're either deorbited intentionally to burn up in the atmosphere, moved to a graveyard orbit for geostationary satellites, or become space junk, a growing problem in orbit. That's why modern designs now include re-entry plans and debris mitigation tech. Fun facts and misconceptions. Satellites don't hover unless they're in geostationary orbit. You can see some satellites like the ISS with the naked eye. There are over 6,000 active satellites and tens of thousands of pieces of space debris. Despite this crowd, orbital paths are managed carefully by space agencies to avoid collisions. Satellites are the unsung heroes of modern life, quietly orbiting Earth, doing critical work every second. And now you know how they stay up there, defying gravity with the perfect balance of speed and science. Liked the video? Smash that like button, subscribe to Astrotech Universe, and comment below. If you had your own satellite, what would you use it for?